Welcome back. As I said, don't really have a lot of time for this, but I'll still do interesting problems. So I guess let's do some problems. First one, this is in the textbook. I think this is page 27, number 34. I think this is the problem. Factor it completely, they said. 2x cubed plus, it's not 12, it's 13, x squared plus 15x. And they want us to factor this completely. Alright, let's do it. The first thing we can do is take out a GCF, so let's take out 1x because it's the greatest common factor. And in these parentheses, we'll get a 2x squared plus a 3x plus a 15. Notice that the a term here, so I like to call this the a term. And here the coefficient on the a term is greater than 1, so the coefficient is greater than 1. And that can pose a problem, but there is a method that I showed you like a while ago that solves this problem, and you can factor basically anything with this method. So let's just have the x stand by over there, and then we don't know what we'll put here yet, but let's do some math on the side here. So to factor this kind of problem, and I'll have a link somewhere leading to it, but you multiply the a and the c terms first, right? This is the c term. So when you get that, you're going to have 30x squared, because you're multiplying 2x squared and 15. Now we need to think of two numbers that, oh, this is a 13x by the way. We need to think of two numbers that multiply to this, besides 2x squared and positive 15. But also add to 13 plus 13x, because our goal is to actually substitute this b term with two terms, but are equal to the b term. And if I, wait a second, that's not right. Alright, 5x plus 6x, it could be 30x squared, but it doesn't work. That's 11x, so that's not what we need. If we did 10x plus 3x, however, that is 13x, and it does work. So now we can actually substitute this 10x plus 3x thing into the b term itself. So now we'll have a 2x squared plus, and then we can substitute our 10x plus 3x plus 15. Now we can just split into two groups and find the greatest common factor of both. So here we have a 2x with an x plus 5, and then here on this side we have a 3 as the greatest common factor with an x plus 5. And of course it's always going to be the same binomial if you do this right. So now the x on the outside, we bring the 2x plus 3 out, and then the x plus 5 stays the same. And we have cracked this problem. I'll just do one more because, you know, I'm that dude. So I spent a bit of time on this one, so let's do this. 3 times x minus 1 squared minus 12. This is actually number 40 on page 27 or something like that. So, I don't know how you guys did it, but this is how I did it. First, I expanded this x minus 1 squared. I expanded that. So when I do, it's going to come out to x squared minus 2x plus 1, and that's all in parentheses, right? And then minus 12, the 3 here. Now I distribute this 3 across the entire trinomial here. So when I did that, I got, oh, wrong color, switch to blue. When I did that, I got 3x squared minus 6x minus, no, what did I do here? Plus 3. Plus 3. And then the minus 12 here. And now I can combine like terms. I can do 3 minus 12 here on the last two terms. So that's going to be a 3x squared minus 6x minus 9, I believe. And now that there are only 3 terms and it's simple, we can find the greatest common factor. That is supposed to be a 2. And now we can just solve. And there we have it. My ice cream is melting and I want to eat it, so see you guys.